absolutely precise. We want kids to develop precise meaning. So we can go on. I think we're jumping into our,
Sometimes,
oh,
is that,
no, the next one. And if you'll indulge me a little bit, this is not the activity we're going to do. This is a first grade activity. I'm going to be curious how many of you have seen that, have seen this situation when we talk about it. Here's a problem, a word problem that we might give, an actual problem for many first grade kids. 3 birds were sitting on a branch. Some more birds flew in to join them. Now there are 7 birds altogether. How many flew in to join the original 3? Becomes the question. It is cute. It is cute. I just mentioned there that we used to tell kids to get your answer to this, subtract 3 from 7.
plus for a kid, if some are joining, why would you subtract if there's
Exactly.
a joining that's happening, and then it causes a whole cognitive dissonance?
It does.
Like,
Oh.
what do you mean?
Yes.
But then you should label them with a learning disability.
This is first grade.
This group is, what's the word I want? I love it.
Candid.
Candid. Candid. I mean, this happened a lot, guys. This happened a lot. Most first grade kids truly focus on the meaning of the word problem. They're not looking for a shortcut to how to get the answer. They are willing to reason about the problem. And previously, we talked them out of that.
Well, I think also my 6th graders and some 7th graders don't grasp the counting up.
Yes.
I mean,
Yes.
that I'll explain to them that just you're starting at 3, how many more you need, and I'll do it with my fingers.
Mhm.
And then when kids do it themselves, I have 6th graders that will start at 1 again.
Interesting.
And not understand
Oh my
that you
gosh.
can start
Well,
at
then
3.
that leads to the life application of giving change.
Right.
Have you ever-
There you go, there you go. You know, the way first grade kids solve this problem, if we just back off, give them the problem, is they find something to represent the birds. You know, 3 little birds, and they were joined by some more, and so we'll see kids take a handful, and then they count them all, and if I don't have 7, I've got to adjust this sum till I get my answer. Do you follow what I'm saying? You know, and they get such good number sense from this. Oh, I can begin to sense when what I tried to add on here was way beyond what I needed. And I think when I hear a situation like that you described, those kids have not had these situations at the age when it can be learned in a way that supports the algebra reasoning we want to teach higher.
And it's very difficult going back to teaching.
It is very difficult.
I was wondering
It
if
is
there was a
very
magic
difficult.
wand or something.
I will tell you this, I was
Fix
working,
that.
my same group of middle grade students, I wanted them to think about the 15 minus X to represent the other side as one way to do that. And what I ended up doing, let me think if I can remember this, we put dry pasta in a bag, so many pieces of dry pasta, and then it's 2 different types of pasta. And one was it was Christmas time, one was actually Christmas tree pastas, and one was something else. We put it in the bag. Then we told them how many total were there, and we took out the Christmas trees, how many of the other type would be there. And at that point, by the action of taking away, they could
Minus the
then think
Christmas trees.
15 minus such and such. But, you know, professional development needs to begin much earlier than for you all, much earlier. And many times we're in situations where we're trying to deal with problems that have not been.
You just
addressed.
reminded me of a problem that came up in my pre-algebra class, where I was trying to group them into groups. They had to be in a group of 3 or 2.
Uh-huh.
So I just said, how many different ways can we group this
I
class
love
into
it.
groups of 3 and 2?
Oh, I love it.
And did the bingo chips, and
Yes.
they did not want to use it at first. They just wanted to,
Mhm.
but they needed that. They needed to do
Because they
that.
don't understand the basic principles that adding is combining, subtracting is taking something away.
Yes.
Like just going through word problems, they're like, well, I need to look for the word that tells me.
Yeah, what to
No,
do.
What's
Our-
the idea? Like what's physically happening?
Yes.
Because
What's
the
the
words.
big picture of this
Right. the words can get very confusing because they
Easily.
don't mean the same thing in every context.
And for a while, we just taught word problems where you could pick out words.
Yeah,
Oh.
of means multiply.
And then you get, yes,
And then,
yes.
yeah, like, what?
Yes. And I don't know who said it this morning, but this whole idea of, okay, I'm gonna start my instruction with a word problem, I may have been you, Tim.
Yeah.
And then I'm gonna worry about learning the arithmetic fact of 3 and 4 and 7, all the addition and subtraction facts that relate those numbers. I'm gonna worry about that later, but I'm gonna focus on problem solving, on
Well,
solving the
but you
problems
might not
first.
even need to teach it because the kids might be able to come up with
With
it. But if you
experiences, they
never-
begin to pick it up,
You
yes.
never give them that option, then
You never
they're-
know.
Yeah.
So, yeah, the research that supports this, by the way, this stuff was done in the early 80s at University of Wisconsin-Madison. And I call it the original flipped classroom. What they found were kids that they had low expectations for just blossomed. In the end, they followed them for 20 years. In the end, those kids were not mathematically brighter than kids who had a traditional curriculum, but they were far more willing to persevere in their problem solving because they had come to learn early on that if I apply my thinking here, I can figure this out. Enough of this. It is cool. It is cool. I think we're ready now. Oh, let's see. You know how I am. Can I figure this out? It's this one.
Can we get it
I
on?
think it's this one?
Yeah.
Did you just touch that bottom arrow?
I don't even have, oh, one last thing. We wrote the number sentence, the equation model, after the problem was solved, when we're working with kids. So this becomes a representation for the real world situation of the birds on the branch.
Would you go right to numbers, or would you want to model with,
Like, right, birds there plus birds flying in equals total birds.
or even drawing the birds?
Yeah.
Or,
Because it is.
like, would you want to go straight to
This is the
numerical?
last
Right.
thing we do. This is
Right.
the very last thing we do. So that this now has meaning, because
Mhm.
I've reasoned this problem, I've modeled this problem physically, I've talked through, or I maybe have used bird models to work this out. The number sentence becomes a model of the situation. More?
Yeah.
Other questions?
Well, I was just gonna say that I think it's interesting that even though this is a first grade problem, and for example, Patty teaches up through calculus, we can see the application and see where it's going. So it's very good because we're looking at this vertical curriculum and where does the situation start? Where are we coming from? And if they don't have this concept, you can see why they're having difficulty in your class.
And remember early on today, we talked about the people who revised the Common Core standards kept in mind the notion of coherence, the notion of rigor, the notion of focusing in on what we want to accomplish. When we see that vertical alignment, we're beginning to get a sense of what will make a coherent curriculum for our kids. So here's our problem. You may have seen this problem. This is from a textbook, Integrated Math, that was popular in the late 1990s and is less popular these days. I'll put it that way. Imagine a piece of string that is bent back and forth to form 3 horizontal layers. Here are my 3
Oh,
layers.
they can't see them. Why don't you, do you wanna draw it on the board, on there?
Sure. And if I were working with younger kids, I'd actually give them the string because, as somebody said, there are kids who haven't really handled physical materials. Thank you, Mary. I didn't need you to get up.
We had
Perfect.
looked at this PowerPoint and we had done it, but for some reason this is not showing up.
So now imagine that you cut across, and I'll let you draw that too, Mary, the bent piece of string with the scissors. How many separate pieces are going to be formed? I'll let you
4.
look at that for a minute. 4 pieces. Do you see the 4 pieces? Yeah, some kids would need to make that cut in order to see those pieces, wouldn't they? So what we're going to do is look at this process where we increase the number of cuts and where we increase the number of folds or layers that we're taking of the So suppose we're making 2 cuts now. Go ahead, Mary. Thank you. And I'll just let you tell me, how many pieces of string do we have now? 6, 7. And in the one with 4 layers? That's what I'm getting. 13. Now, in the process of doing this, yeah, I'm putting you at a disadvantage because I haven't let you do any drawing yet, and it's a little hard to look up here and coordinate your counting with the number of pieces, isn't it? At least it is for me. Do you see, now having talked about this, do you see any assumptions that we've made or I've made in this process?
What would your students say?
Could I make a cut here?
Is that considered?
Where
a
the
cut?
blue line is, that little blue line?
Mhm.
Well, it's not gonna cut anything, you can move the scissors.
Yeah. So I have, you notice none of the cuts we took actually went across, skimmed or intercepted one of the folds. Yeah. One of the things when we want to teach with modeling is that some real-world situations are so full of crazy things that we have to limit those in some way. We just have to put a limitation on that if we're gonna deal with the situation at all in an organized way. So in this case, as contrived as this situation is, and it is a little contrived, I mean, who's gonna sit and cut string this way? Maybe if you had need of a lot of little pieces of string, you'd run it back and forth and cut a bunch at a time. But one of the assumptions we're making here is that when we make a cut, so to speak, it's gonna go through each layer of the folded string. And it's not gonna miss anything or cut across anything. So I have for you this activity that I'd like to have you enjoy for a minute. It includes what we've done so far, and it'll take you a bit further. We'll talk about the process involved as you explore this a little bit.
Are you trying?
Particularly with number 4, what is a layer? I've been using that word. What is a cut? I think that'd be a good place to start. What is a layer? What is a cut?